Well, props to people who have been here since this morning. I recognize a few faces. Only 2 more talks, I promise. So today we're going to talk about Inco. So what is Inco? Inco is what we call the Universal Confidential Computing Network. So this talk is going to be a lot more focused on crypto and blockchains in general. Today, if you look at all the existing L1, L2s, you'll notice that they all have one thing in common, which is everything is transparent. Now, for mass adoption to occur, we actually believe that there needs to be a minimum of confidentiality. So just a couple examples. Today, when you use crypto as your bank accounts, everyone knows your balance. Or if you use crypto for payroll, all the employees know exactly how much everyone's making. And this is a bad practice in Web 2 already. Second, institutions and enterprises are still having a hard time entering the space. They've tried things like Hyperledger, R3 Corda, but it's fundamentally not the same thing. So, institutions have compliance reasons. They also have, trade secrets. There are many reasons why transparent blockchains are not very suitable for them. And the third piece here is there are just a lot of use cases that wouldn't make sense on a transparent database. So you think about the card games, the private voting, or blind auction. So what we're building is what we believe to be the 4th missing layer of the blockchain stack, the confidential computing layer. So if you think about the modular stack that we have today, you have folks like Celestia building DA as a service. What Inco offers is confidential compute. And so with this, we believe that this is the next frontier. Just like how Chainlink enabled a whole suite of DeFi ecosystem to unfold over the years, you think about the money markets, derivatives markets with Oracle services. We believe that will enable the next frontier applications across gaming, DeFi, asset management, and also infrastructures. And I think Nigel earlier actually made a really interesting remark that the early internet, without SSL, actually the only thing you could do is mostly academics. You couldn't do any business on it. So this has actually got me thinking a lot more about what we're doing. Ultimately, with the encryption, what we're doing here is not just privacy. We can really just enable a lot more use cases and adoption, and that will really lead to the next $1 trillion of economic opportunities within crypto. So what is FHE? I think by now everyone knows what FHE is, so I won't spend too much time on this. But for folks who are non-technical, one example I'd like to give is imagine you have a cat picture. You were to encrypt this picture, you can still modify the pixels by doing FHE. So you can add, divide, multiply every single pixel, and by the time you decrypt, now you have a filter. So it's really a cryptography that allows you to do computation on top of some kind of encrypted data without knowing what it is. Now there are legacy, privacy solutions in the space. When I say the space, I refer to the crypto space. ZK is probably the one that everyone thinks about when they think about privacy. I would say what makes FHE really stand out here is really around the idea of composability. So why do you need composability in crypto? You need composability because cryptos or blockchains in general are multi-party systems. So if you use DeFi, you do gaming, you have to interact with different people's states. Oftentimes these are shared private states. So without composability, you're fundamentally limited to the use cases that only make sense if they're single player use cases. So for example, if you want to prove your age, your wealth, I think that makes sense. But if you want to build anything that involves multiple people, then you want a system that's more permissionless and composable. So Inco, you can see us as a new layer. And what we offer here is decentralized compute, confidential compute, but also storage, because we have to store your ciphertext. And so the plan for Inco is to service the major blockchains, such as Ethereum, the major L1, L2s, but also the rest of the blockchains down the line. We offer the most intuitive way for developers to write code, so they get to write FHE code directly on existing chains. And with that, the benefit is that they also get to tap into the existing user base, as well as the TVL. So the way we design our decryption network is also very modular. Previously, a lot of the feedback we've gotten from Inco is that why should I trust the Inco MPC if that's ultimately the network that determines all the values that gets decrypted. Now with this new system, you actually get to choose which MPC network you want to trust. And this could be based on a few factors. It could be based on the brand, the tech that's being utilized, or even the geographic locations, right? So maybe with GDPR, you need to trust an MPC system that's based on a specific region. And so with this approach, you basically don't have to fully trust Inco MPC. You can also bring in your own keys or trust a specific network. So a lot of the issues or challenges as a new layer one has to do with this co-star problem. So what is the co-star problem in L1s? The co-star problem is this. Your market cap is not going to be as high, and because of that, you have more volatility. So what this means in terms of stakers is that you have a lot of inventory risk for holding these assets and staking it. So typically what layer ones do is they give out a lot of inflation, so 20 to 50% typically. Now by leveraging a more mature asset class such as Ethereum that we're doing through EigenLayer, we actually avoid this problem. But not only this, we actually get to rent a lot of economic security since day one. So we solve a lot of this typical L1 co-star problem in this methodology. So we offer the most intuitive way for people to get started. We're fully compatible with existing Ethereum toolsets, such as Hardhat, MetaMask, Remix. And this is, I would say, one of the biggest differentiation compared to existing privacy toolings. It's really the familiarity and the ease of getting started. So we utilize the scheme, the TFHE RS library, which, with the TFHE scheme, what's important to note is that it supports a pretty wide range of operations, including comparisons. So really, this is making it very easy for developers to refocus on creativity. So if you want to build some kind of private DeFi or gaming, you can really recreate any logic you have in a private manner. So I think here, just to maybe expand a little bit, why is this important? So if you think about blockchains, they're all transparent databases. The way you build use cases in Web 2 is you have a server. So if you build something like eBay, if people submit bids, your private server actually hides all the hidden values, right? And they only expose the winning bid at the end of this process. Now, because blockchains are public, there's no concept of private state. So what you need to do is actually use encryption to mimic the same effect. So what you do is you encrypt private states, but not only that, by leveraging FHE, you're able to compute on top of this private state. So you're really recreating this whole idea of private state that we have in Web 2 that is not feasible in Web 3, but by leveraging FHE, you actually get to a very similar type of experience. So maybe just to talk a little bit more about use cases. Today, we've seen a lot of folks talk about AI. We've seen folks talk about MEV protection, blind auction. So just wanted to maybe focus a little bit more about what can you actually do with FHE on-chain. So one example I like to give is really this concept of confidential ERC20. It's very simple. It's your regular ERC20, but the balance is hidden. So for folks who understand Solidity, all you have to do is map an address to a EWINT, which represents an encrypted balance. And when you do an ERC20 transfer, you're just sending an encrypted amount to an encrypted balance, essentially. And then you're also reducing your balance by this encrypted amount. So a couple of differentiations here. So one is this experience is actually what we have already every day around us. So if you think about PayPal, Venmo, Revolut, you can see that your friends have sent money to each other, but just not the amount, right? So this is not a new experience. And these Web 2 applications, if you think about it, these are not even privacy apps. These are the bare minimum of confidentiality that we need in order to feel comfortable using these type of applications. So this is the same kind of experience that we can recreate on-chain. The idea is that you can trace the flow of funds, just not the amount. Another example is just card games. So it's almost crazy to think that we still don't have a fully on-chain poker game in crypto. There are a couple of reasons for that. So poker is a bluffing game. So if you're not able to hide value on-chain, this game would not make any sense. And second, with the existing tools that we have today in crypto, for randomness, so Chainlink is a leader in the space. What they offer is only plain text randomness. But for this game to make sense, what you have to do is generate hidden randomness. So we derive this from FHE. So we're able to generate a string of random bits, and then from there we can represent cards. Another use case that I particularly think is very novel and also a little bit interesting is the concept of DID. So today, if you want to get some kind of DID, what you do is you KYC with folks like Binance. They will send you a soulbound token that says, hey, you're over 18, are you in Europe? Do you have a good credit score, right? Now this is very inconvenient because this means all the information is completely public. You're not able to selectively reveal information. And not only that, this information could also change over time, right? So what happens with the concept of dynamic DID is that, imagine this, you can encrypt your credit score or your age, which could be, for example, the date of birth in terms of timestamp, right? So you encrypt that information and you store it on chain, and then you can selectively reveal what type of insights you want people to know. So the way this works is pretty straightforward. All you do is an FHE comparison. You compare if your credit score is above 700, and then you do a decryption on the specific insights. So with this approach, actually you never reveal the actual information. And if your credit score changes over time, the selective information you reveal will also change over time, right? So for example, for a casino dApp, maybe I just want you to know I'm over 18 and nothing else. Maybe for something like Goldfinch, money markets, I just want you to know I have a good credit score and hide the other information. And again, if you think about this, this is still a Web 2 experience that we cannot have in Web 3. The closest experience that I can think of about this experience in Web 2 is just Google Auth. With Google Auth, when you connect to an application, you say, I want you to access my calendar, but not my calendar, but not my contact list or Google Drive, right? And so that experience is exactly the type of experience that's missing in Web 3 that we can enable. And if you take a moment to pause here and then think about everything I just said, a lot of these use cases have nothing to do with privacy. We're just talking about things that we are used to use in Web 2 that's missing in Web 3. And the piece that's really missing is really this concept of private states that I mentioned earlier. So with that, we are hosting, so we're sponsoring the ETH Global Hackathon this weekend from Friday to Sunday. So if you are a builder, it's a great opportunity for you to try out the tech that we're building. So we have a $10,000 bounty and 2 tracks. So one is gaming, the other one is open innovation, which includes DeFi infra. Gaming, I would say, so far has been one of the more popular track for a lot of the builders because it's just very easy to build simple games, but also you can also actually create novel games. All the games that we have today in Web 3 are not as challenging because you have perfect information. And if you think about all the games that makes a game, all the mechanics that makes a game fun, require some kind of hidden information, such as bluffing, secret alliances. You can spy on people, fog a war. So this is where there's a lot of folks who are generally excited to build games. And second, there's also quite a bit of use cases around infra. So DID is an example, private voting, but also private DeFi. So today we had a really good talk from Tarun about what are the design principles you should think about when designing for private DeFi. And yeah, I urge people to think more about how to design around like private AMM, money markets, flash loans. There's quite a bit of open space here for people to try out. And if you don't have a good idea of what to build, we also have a Notion list here that can inspire you to build things. And then feel free to join our Discord group. We always have folks answering questions, and then we're always happy to provide any feedback. We also have a Telegram group here that you could join. And lastly, yeah, we do have a testnet running. So if you want to build any use cases, you can get testnet tokens and then try around. So yeah, that concludes my presentation. And then yeah, for more information, you can find us based on these links. And if you also want to try out the novel experiences, you can also try out the arcade page, which has a few applications deployed. Thank you. So yeah, I can answer questions. Someone might have to run around with the mic. Any questions? Okay, one question.
What's the most prominent application that you see, like either users or as you as Inco, like building?
Yeah, I would say we've definitely seen a lot of games. So we've hosted 3 hackathons so far. We've definitely seen a lot of games, mini games. Some games are simple slot machines. Some games are guessing games like Hangman. A lot of guessing games, I would say. In terms of the more established companies, a lot of it has to do with payments. So you think of stable coins, payroll, these use cases. And also some folks have demand for governance. So governance in a way is still a unsolved problem, I would say, in the crypto space. What I mean by governance is private voting in general. There has been several attempts, but none of the solutions have really captured the entire market. So I would say governance has been also a pretty important area. Cool. Well, thanks everyone.